Hydraulic cylinders are one of the most powerful and effective ways of creating linear force, Josh. What is the most common design that's used out there?
Like so much of fluid power, there's no set standard one can go by to find the most common design. That being said, the welded type are very common, and most manufacturers tend to build them the same way. The welded cylinder is simply a barrel with a cap welded to the bottom. The mounting treatment is then welded to that cap, typically a cross tube or dual tangs that mimic a clevis. The piston and rod are installed into the cylinder, and then a threaded head is slid over the rod and torqued onto the barrel. Finally, the rod treatment is added to the cylinder, which is sometimes a cross tube welded directly to the tip, or if the rod was threaded, any other rod treatment that is common to the industry, such as a clevis or a rod eye.
Can you tell us what an NFPA or ISO cylinder is and how common they are?
A lot of hydraulic cylinders are manufactured to NFPA or ISO standards. Cast tie rod cylinders are welded cylinders, are used heavily on mobile equipment, but the NFPA and ISO standards for tie rod cylinders are the most common in a high-end hydraulic machine. The metric ISO standard for cylinders is quite similar to the National Fluid Power Association standard using imperial units. ISO and FPA even use the same 3-character alphanumeric code for mounting options, such as MT1 for head trunnion and MP1 for fixed clevis.
So why are they so popular?
Their advantage lies in the modular nature of the parts used to create a finished product, such as the cap, barrel, head, and rod sizes, which allow the cylinder to be assembled in a few days from off-the-shelf parts. Opposite to the rod side is the cap, which is essentially a block of forged steel machined with a deep ring to accept the barrel, which seals with an O-ring. The cap end is typically very simple, with just a port machined to direct fluid into the piston side and 4 drillings for the tie rods and sometimes a cushion screw. Opposite to the cap end is the head, which is more complex and consists of more parts. The cap must also contain a bushing, a gland, and a rod seal package. The standards for tie rod cylinder design apply mostly to the mounting dimensions, and less so for the internal design of the cylinder, which can vary significantly from manufacturer to manufacturer. These differences can exist with piston design, head design, rod gland and seal design, etc., but the exterior mounting dimensions must remain the same, such as retracted length, clevis pin diameter, or trunnion dimensions, if so equipped. A basic cylinder comes with no end treatments. However, by simply drilling and tapping 2 threads, each in the cap and head, we create the MS4 side flush mount cylinder. Just one of the many choices. Each popular mounting style has its advantages and disadvantages.
That's a lot of letters and numbers, Josh. How can you keep them all straight?
That secret, Mary, is for another day. After a list like that, I need a break. Next week, we'll go into more mounting designs and we'll see where they're best suited.
We'll be waiting with bated breath, Josh. Stay tuned for next week when we talk more in depth about hydraulic cylinder mounting. And as always, visit www.fluidpowerworld.com for more videos. Thanks for watching.